Hi class, today we're going to do another day of comparing data in dot plots. So it's really important that we're focusing on the dots on the plot and really looking at what they tell us. So the key factor is going to be the vocabulary terms. So we're going to compare two groups of data in dot plots by writing descriptions of the shape, center, and spread, which is what we did yesterday. And today we're actually going to create dot plots from given data. If we have time today, we'll also do an activity with a partner, creating a loop. So what I want you to do is go ahead and press pause and try to come up with the vocabulary terms described here. Okay, take a look. Did you get the terms right? So the mode is the data value that occurs most often. So you're looking for the, kind of column or the number that has the most dots above it. That's going to be the mode, and sometimes there's several. If several of them have 5 and that's the largest number of dots, then both of those would be your modes. The median is the middle value of data when it is in numerical order. It's also known as the center. So the median is where you're taking the center value, or you can cross them out working from the outside in. If there's an odd number of dots, there will be one point that is the center. If there's an even number of dots, you'll have to look at the 2 dots at the center and then average them out, which means you're going to add them up and divide by 2. So if we were at 10 and 11, the median would be 10.5. And a dot plot is a type of graph used to analyze a data set, especially with respect to its center and spread. Okay, so now give these 4 a shot. Press pause and then I'll check your answers. Okay, so now go ahead and check these. So center is where there is an equal amount of data on each side. Shape discusses the symmetry and distribution of the dots. So that's where we're looking at, does it kind of look like a rectangle? Does it come up to a peak and look like mountains or a skyline? That's what we're looking at there. If there's clusters, like maybe from 2 to 4 and then there's a gap, and there's no other points until 8. And then outlier, a value much greater or much less than the others in the data set. So you also need to look at how, the increment that the data increases. So if it increases by a half and there's only 2 spaces, well, that's only a difference of 1. So is that really an outlier? Is that really far from the others? So really take all that into consideration. And then range is the difference between the greatest and least values in a set of data. So make sure you know we're looking at the dot plots, or the dots on the plot, not the numbers on the line below it. So even if the numbers on the line go from 16 to 2, and the dots go from 3 to 15, we're looking at the 15 and 3. So it would be a range of 12. Okay, so take a moment and think about this. So why do outliers affect the range of the dot plot but not the median? And go ahead and write this on your notes using the sentence stem. Outliers affect the range of dot plots but not the median because... Okay, so outliers affect the range of dot plots but not the median because it doesn't change the number of dots on each side of the center, or it doesn't change the number of dots at all. They're just spaced out differently. So it's going to affect more the distribution and symmetry, or the shape, but not the median. Okay, so let's take a look at these 2 dot plots. So it says one is for science tests and one is for math test scores. Visually compare the dot plots of the scores of 25 science tests to 25 math tests. So the science test is centered around what? So we're going to go through and say, okay, so we know there's 25. So that's an odd number. So there will be 1 dot at the center. So I'm going to go down to 24. So half of 24 is 12. So that means my 13th dot is the center. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is the center. For science, let's find math. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 there. So we have for science, it's centered around 70, and math is centered around 80. Okay, so the spread for science goes from the high is 90, the low is 20, so the difference is 70. And then the spread for math goes from 100 down to a 30. So 100 minus 30 is 70. So although the spread is different, the range over here for 70 is the same. Okay, so a random sample of 12 and 13-year-olds were asked, on average, how many text messages do you send per day? Here are the results. So what we're going to do is create a dot plot, and I see it goes from 0 to 100. So I'm going to do 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So I'm going to start plotting my dots. So I have 20, 10, and then 100. So 20, 10, 100, 0, 10, 10, 0, 10, 10, 30, 90, 50, so 30, 90, 50, 20, 50, 20, 20, 50, 20, then 10, 50, 100, 10, 50, and 100. So what can we say about the results? So first of all, we want to talk about how many teenagers were surveyed. So each dot represents one teenager that was surveyed. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 teenagers were surveyed. And then we want to describe the shape of the graph. So I would say that there is, let's see, most of the dots, mostly from 0 to 30. And then we have a few points at 50. And then 90 to 100. And the peak is at 10. So then count the number of dots at 0 and 10. What do these numbers mean? So at 0 and 10. So there's 1 at 0. And there's 1, 2, 3, 4. 4 at 10. So this means that 5 sent less than 20 a day. So 5 people sent less than 20 texts a day. And what can you say about the results? So one conclusion that I would draw is that students generally send from 10 to 50 text messages a day, that nobody sent 40 and nobody sent between 60 and 80. So is this really realistic for our world today? Doubtful with how attached you guys are to your phones. Okay. So here's the dot plot. I already wrote the information on the last slide for you. So you should have already been able to fill all these in. Sorry, I forgot I put the picture here. Okay, so stop and jot. So this is on your notes. So when does it make sense to use the median to compare two data sets? So I want you to think about it and go ahead and answer the question. Okay, so here's another example. Daryl and Luke each plan to spend at least 20 minutes per day working out. The dot plots show the number of minutes per day each worked out for the first few weeks. So which of the statements about the two data sets is true? So what I want you to do for each of them, you need to write out the range, median, and mode for each. And then that will help you be ready to compare the two and see which of these statements is accurate. Once you do that, enter it in and check it. Okay, so the list below shows the number of weeks different songs stayed on the top of KRBE's list. So what is the difference between the mode and the median? So to find the median, I have to put them in order. So let me write them in numerical order. 2, 3, 5, 5, 5, 9, 9, and 10. Okay, so the mode is going to be 5 because there's 3 5s. And the median is the middle. So 1 on each side, 1 on each side, 1 on each side. And then it would be between these two, but the average is 5. Okay, so airport A and B. Rachel's comparing data for the number of flights arriving and departing each hour at 2 airports, but she accidentally made a mistake. Which piece of information is inaccurate? So which is not true? So go ahead and I want you to write range, median, and mode for both graphs before you even take a look at your answer choices. And then see if you get it right. Okay, so now you're going to work with a partner to complete the loop, and you are going to work it out on the sheet that says to show your work. Each of you need to have your own document with your work shown, but you guys can have one loop with both of your names on it. So feel free to ask me any questions, but stay on task. Keep your voice level at a level 1, which is a whisper.